Welcome to a course on sequence and series. In this lecture, we are going to see the second limit theorem by Cauchy. Right? Okay. In this theorem, what is given? We are considering a sequence of positive terms. Okay. Here, we are considering only a sequence of positive terms. Whereas in Cauchy's first theorem, it was for general sequence. The terms of a sequence can be positive or negative or zero maybe. Right? Whereas in this theorem we are considering only a sequence of positive terms in which if something limit Sn plus 1 upon Sn exists, then nth root of Sn, limit nth root of Sn will also exist and they are going to be same. Right? So in this theorem they are not saying it is going to be true always. It is going to be true only in a certain case. What is that case? If this exists. Okay. So let us start the proof formally by supposing limit n approaches infinity Sn plus 1 upon Sn exists and is equal to L. Right. So what do we mean by this? If this is going to be a sequence of, positive terms, this will also be a positive quantity, right? So what actually you are having here is S2 upon S1, this is the first term, right? And S3 upon S2, S4 upon S3, you have something of this sort. You may treat this as A1, this as A2, this as A3, and this is going this way, right? So this limit exists means you are having a limit for this sequence. That is what we have written. Okay, we are not explicitly saying these things. It has to be understood. Okay, this is happening. Then there exists some n, okay, a positive integer n. This is existing for every epsilon greater than 0, such that here we are talking of positive terms. That is why the metric is going to be standard Euclidean metric Sn plus 1 upon Sn minus L less than epsilon for n bigger than or equals n. Right? So this is what we have. Now this I may write it as minus epsilon less than Sn plus 1 upon Sn minus L less than epsilon. And this is L minus epsilon less than Sn plus 1 upon Sn less than L plus epsilon, and this is true for what? N bigger than or equals n. Right? So what am I going to do is that from this stage I am going to start. Okay, this result is true for all the values from and after this stage n. First let me do it for n. What happens? L minus epsilon is less than S big N plus 1 upon big N less than L plus epsilon, right? So next, what am I going to get? I am going to get L minus epsilon less than S N plus 2 upon S N plus 1 less than L plus epsilon, right? It is going, okay, to some stage. I don't know what that stage is, so I am having that as simply Sn, right? Now we have certain inequalities, right? Now we are going to multiply all these inequalities. By multiplication, what do we mean? We are going to multiply the left hand side with left hand and right hand side with right hand. So L minus epsilon, how many times it is going to be? So it is n minus n, right? So n minus big N. Less than what? Okay. Here what will be the case? Sn plus 1 upon Sn times Sn plus 2 upon Sn plus 1, and it goes till what? Sn plus 1 upon Sn. So this term gets cancelled, this term. Similarly, the terms will get cancelled, and finally what is going to be there? Right? So here also we will have n minus n. Okay. L minus epsilon to the power n minus big N less than S. Just a minute. Okay, this will get cancelled, this will remain there. Okay, Sn plus 1 upon S big N less than L plus epsilon to the power n minus n. Okay, we have this. Now, we know that the quantities involved here are positive quantities. So, let me multiply this by Sn. So, Sn L minus epsilon to the power n minus n less than Sn plus 1. Okay, less than L plus epsilon to the power n minus n. Right? Okay. Now, what are we going to do? We are going to take nth pair. Okay. Just a minute. Are we right? Or we have missed anything? Okay. Here we are writing till this stage. Okay. So, okay. Then we will have Sn Sn minus 1, right? So these quantities will get cancelled. You will have Sn, right? Yeah. Now also the quantities remain same, right? Now what are we going to do is that we are going to take 1 by nth power on all the sides. So it is Sn power 1 by n, okay, L minus epsilon 1 minus n upon n less than Sn power 1 upon n less than, here also we have Sn, right? So Sn power 1 upon n L plus epsilon 1 minus n upon n. Okay. What is his big N? It is one of the quantity in the sequence, right? It is a sequence of positive terms. Okay. Now, what actually we are going to do is that we are going to make n approaches infinity in this term. Okay. Then what is going to happen? Sn power 1 upon n, 1 minus epsilon, 1 minus n upon n, less than limit n approaches infinity, Sn to the power 1 upon n, less than limit n approaches infinity, Sn to the power 1 upon n, L plus epsilon to the power 1 minus n upon n, right? This is what we need to check. So we will leave this as it is and see what happens here. When we make n approaches infinity, the power becomes what? It is approaching 0, right? And what is this? This is a positive quantity, which means it is going to be a greater than 0 quantity. So this will be what? This will go to 1, right? And this will also go to 1. And this goes to what? 1 minus 0, right? So this gives you what? This is L, right? Okay. L minus epsilon to the power 1 less than limit n approaches infinity, Sn to the power 1 minus n less than here all L plus epsilon. Okay, this was true. Okay, here we have what we have done. This was true for after a certain stage. When you combine it, what are you going to get? This clearly tells you limit n approaches infinity, Sn to the power 1 upon n is L. We assumed with limit n approaches infinity, Sn plus 1 upon Sn is L, and finally we prove limit n approaches infinity, Sn to the power 1 upon n is L. Right? Here we have not given any restriction on this L. Okay? So which means whenever your sequence is a convergent one and hence it is a finite limit, this will also be a finite one. Supposing this is infinite, this is also going to be infinite. Right? And this result is giving you something which is very useful in the course of series, which we will deal in after few lectures, right? So there, in order to check for the convergence of a series, we are going to study root test and ratio test. For root test, we will make use of this idea, and for ratio test, we will make use of this idea. We don't need to get confused what to use. Whatever may be the things that we use, both has to give us the same result. Okay, that is what this Cauchy second theorem on limit tells you, and this idea of course we will make use in the course of series. Thank you for watching.